Hi everyone. Imagine you walk into the college canteen. Who do you sit with? Most likely with the people who like the same things you do. Maybe the same sports, maybe the same music, or maybe the same club. Our project is finding these kinds of friendship group at SNU. We wanted to see, can we use data about students, hobbies and clubs to find out which students are likely to be friends. That's where clustering comes in. Clustering is a magic tool that looks at a student's interest and says, hey, these students are similar. Let's put them in the same group. It is useful here because we don't already know the groups. We need the computers to discover them for us.
Now, the detective work, how we find the groups. To do this, we first had to get the data ready. The dataset had information like clubs, hobbies, musics and more. But computers don't understand words like music, clubs or reading. They only understand numbers. So, we turned each interest into numbers using something called one hot encoding. You can think of it like a checklist. Tick yes for reading, tick yes for music, and so on. Next, we had to answer how many groups should we make? Should it be 3 groups, 5 groups, or 10? To figure this out, we used two helpers. One, Silote score. This tell us if students feel they are in the right group. If the score is high, it means students are sitting with the right friends who are like them. And the second is Davis Baldwin's index. This tells us if groups are far apart and not mixed up. A low score is good. It means the group are clear and separate. Once we knew the right number of the group, we use an algorithm called K-mean. K-mean means a teacher who first guesses where the groups are, then keeps moving students around until everyone is in the group they fit best. And then come to the fun part, visualization. Since we can't see 20 different hobbies and club at same time, we use a trick called PCA, which stands for Principal Component Analysis, to sink everything down into a 2 dimensions. Then we drew a scatter plot where each student is a dot and the dots are colored by their group. This way we can see the friendship groups instead of just reading numbers.
So, what did we learn from all this and why does it matter? We looked at the cluster and saw that some group had students who loved coding and science fiction movies, while other had students who enjoyed music clubs and action films. Each group had its own personality, which was really exciting to see. Our scores also told us that groups we found were meaningful. The Silote score showed students were placed in groups where they fit well. The Davis-Baldwin index told us the groups were nicely separated. So, how is this useful and where can we implement this? The student union at SNU can now plan sitting in common rooms so that students sit with people who share their interests, organize events for each group based on what they like, help students find new friends faster by connecting them with the right group. In short, clustering helped us discover friend circles, something that wasn't obvious at first but is really useful once you see it. And based on their preferences, we can divide them into groups and help them communicate faster with each other. That is all. Thank you for listening.